Hello, everybody. We are the Botlink Capstone Group. I'm Alex Zink. The group consists of Tien Pham, Chandler Ramsdale, Travis King, and our sponsors Andrew Paulson and Paul Clapperich. Who is Botlink? So Botlink is a drone software company based out of Fargo. They're paired with a hardware company called Packet Digital, and their main applications are mapping and surveying applications. They are focused on making drone operation easy for everybody. The problem that they came across is that indoor drone use is very difficult to do. And in law enforcement use cases, they require months and months of training. So the opportunity that they gave us is to create an application to simplify indoor operation, which would then shorten training time and costs for those law enforcement agencies. Our solution involves an Android application that would display a video feed from the drone along with LiDAR and ultrasonic sensors. It would host controllers to send controls to operate the drone and connect to the Raspberry Pi. The Raspberry Pi would be on the drone. It would host the camera and the sensors that would then send the data to the Android app. It would also connect to the Pixhawk 4, which is a device that would communicate between the Raspberry Pi and the drone to prevent collisions and send controls. Now to Tien for the schedule.
All right, thank you, Alex. So for the schedule and how we split up each sprint during the project is that during sprint 1, we did not have much at first since we were waiting on the hardware. So what we did was we started the app creation and made a basic app that can launch on a emulator or a phone. And then during sprint 2 is when we started getting a little bit of hardware where we got I think a single Raspberry Pi, and that Raspberry Pi had a camera. So what we did was implement a way to stream the camera from the Raspberry Pi to the app. And then for sprint 3, this is when we got most of the hardware and everything that we needed to start working on it fully. This is where we created a graph overlay on the app. And then also with that graph overlay, we had an altitude meter UI and a battery indicator. And then we also on the Raspberry Pi, we created a couple of Python scripts to get the collected data from the sensors and send that over to the Android app. And then for sprint 4, we got both the altitude meter and the graphing overlay to start updating real time with data that's being collected from the sensor on the Raspberry Pi. This is our demonstration for the app and everything we had during the semester. And there you go.
Hello, this is our capstone project demo for Botlink. Our group members are Tien Pham, Travis King, Chandler Ramsdale, Alexander Zink. The first part of this demo, we're going to show the hardware involved. So this is what our project hardware looks like. Obviously, and the next slide will show them labeled. So this is from our sponsors, this image clearly labeled. Obviously on the left is just the power input. The second part on the upper left is the LiDAR. That is the hardware that scans the room and tells the distance from objects in a circular pattern. The next part is just where the LiDAR connects to the Raspberry Pi. Obviously below that is the Raspberry Pi. We have a serial connection to the Raspberry Pi where we can change things on the Raspberry Pi. We actually ended up doing an SSH network so we could all edit it on the web. Now for our second sensor, we're using rangefinders. We have an upward rangefinder and a downward rangefinder. Basically that will tell us the distance in inches from 6 to 255 inches. We're using a Pi camera for our video. Our flight controller is to the left there. That takes inputs and sends our input from our Raspberry Pi to the drone motors. It can also change and accept mapping data. And then on the left, we have our power supply, which just comes from our power input. So then on the Raspberry Pi side, first thing we did was install software for Botlink router. It allows ground control stations to upload missions to our flight controller. That just allows us, if we send a waypoint, the flight controller will be able to fly the drone to that waypoint. Basically, we had a map from our Android app through the Raspberry Pi into that flight controller. So it's just a 2-network process. And that is it for that part of the software.
All right, guys, this is Tian Pham from the group. I'm now talking about another part on the Raspberry Pi. This part is to grab for this part, it's 3 scripts of Python. Each does its own thing. The first script, which is runs the LiDAR and spins the motor, and that will start collecting the data. And then the second part, or the second script, is the ultrasonic one, where it will read from the serial port and then trigger a GPIO power output onto it, so that it can read for a 0.0001 second. And then the last script is the camera one, where it'll read from the camera and send it to a HTTP server, where we can view that on any browser or through the app. So then for running the program, I have a couple of lines I have to write out here. For the LiDAR, I have it's running in Python 3, so when it runs, you have to believe me on my word, but it does give us an error at the beginning, but after that, it should be fine. But here is what a video of the LiDAR when it starts running. All right, that's a quick video there. So that's just for the LiDAR, and then another line for the US, or the ultrasonic. When you run that, it will print up the range from the upward ultrasonic, and then the data for the downward right there, up, and then just constantly do that forever until we close the program. And then for the last one, we have Python 3 still, and then this one will run the camera. Oh, wait, I spelled Python wrong. Camera. All right, so back to the slides. That's all about how we did the Raspberry Pi. Also, the Raspberry Pi are transferring that data they collected through the sensors to a socket that has been programmed with a library called 0MQ. And for our second part of the project, our Android app is how we set up the Android app and how the Android app is reading data from the socket and displaying that data and everything. So let me run the program here. So this is our basic, really basic app we made out for the project. So there's a basic menu on this with home and then the drone camera. So if you click on the drone camera, it takes a while to load everything since it's still in a work in progress state. So yep, the camera's right there. You can see the camera. And then this is a rangefinder, or the ultrasonic sensors, where it shows you the range of the ceiling and the floor. And this is the little graph of mapping the LiDAR out. There goes LiDAR. So how the LiDAR works is I have a array reading 50 points from the the Raspberry Pi script that's sending the data over. I have it read 50 times, put it into an array, and have that array sorted by assertion sort. And then with that assertion sorted array, I have that put into a series, and then the series will be plotted onto the graph, which is what the graph looks like right now. So it's only showing 50 points on the graph. And if Travis wants to explain a little bit about the altitude meter and everything, you can do that real quick.
All right, so the altitude meter reads in data from a TCP socket, which we're going to switch into a UDP socket. But as it stands, it just goes 4 feet from the max for both sides. If it reads data over 4 feet, it just puts it a green bar all the way to the top or the bottom. Anything under 20 inches, we have mapped to yellow. Anything under 6 or below is mapped to red. So the top sensor, if you want to move your hand about 20 inches above, should switch to yellow.
Putting my hand in front of it right now. Takes a while to update.
We found the main thing that was slowing down our Android app was we're using a MJPEG viewer on our Android device, which is megabytes of data on our main processing thread. So as soon as we switch that to RTSP streaming protocol, it should speed up our app tremendously. And anything else you want to add?
Let's see. I think in conclusion, that's our basic demo. Like Travis said, we would be changing the MJPEG viewer to a RTP stream viewer rather than that, so it'll be less laggy on the video side. And I think that's everything for this demo.
Hello, this is our all right, and then I'll be talking about our risks and issues we had during this project. Obviously, what was left off with that conclusion, our RTP stream is the correct way to stream our video. It uses less data overall, and we could send the data fine through a Raspberry Pi, but Android, for some reason, did not like our taking to our implementation. Another risk and issue we had was we only had one Raspberry Pi for 4 people. With COVID-19 happening, it made it really difficult to have us all access the Pi and access all the LiDAR. So one person could really only work with the LiDAR when Teen was around, since he had the Raspberry Pi. The last issue was time. We had a late start to early misconceptions regarding the length of the class. They thought it was 3 months and 3 semesters long, and we had 1 semester to do it all. Our scheduled meetings also, we had to schedule our meetings around 4 different work schedules. And now to Tien for the postmortem summary.
All right. For the postmortem summary, so for the hours we did during this project was that our estimated user story points was 56. And then for our completed user stories points, we had 90.
Sorry to interrupt, Travis, you're on the wrong slide.
It's not working. There we go.
All right, and then the number of lines of code we wrote was a total of 1,362. And then for the effort and how we split what work we did most throughout the project was that we put it in training where we learned about the hardware and how programming that works and how the Android Studio works, and that took about 15%. And then the requirements are for the paper of the spec document, and then the sprint reports and weekly reports are all about 15% of that. And then designing on how the program should work and how the app should be programmed was about 10%, and then actually coding everything was 45%, and then testing everything after that was 5%. And then for this midterm and final report, it took us 10% of our time and effort.
All right, so then the next steps that will be for this project, they'll go forward with Botlink, is they're going to implement controls on the Android app. With our Telem1 connection we have on the companion computer, it should automatically send whatever controls we send from the Android app to the Pickox, so you shouldn't have to worry about that. It'll just be on the Android app. Then they need to make sure the drone works with other ground control stations. Again, as long as they're connecting directly to the drone itself and the Raspberry Pi, it should go to the Mavlink using Mavlink router. They're also going to be using our app as a baseline to create their own robust app and use that app going forward for indoor flying. They would also like to implement more graphical interface options, and then they want to update the companion computer's collision avoidance on Telum 2 to help prevent collisions on the inside. Thank you for watching our review. This was the Botlink presentation.